Problem 30, we have a student sits on a freely rotating stood. We have the stood holding two weights, M1 and M2. You know, M1 equals to M2 equals to 3 kilogram. M1 with a weight M1G and M2G. Initially, we have the axis here, and we have a rotation clockwise, anti-clockwise. M1 and M2 was initially at a distance of 1 meter from the axis. Here we have 1 and 1. Okay. The initial state, we have omega initial equals to 0.750 radian per second. And also I give you the moment of inertia of the student with a stood, okay, for this system only, without the two masses. Here, I of the student plus stood, we can say FIS initial equals to 3 kilogram times m square, okay? In the case where the arms are extended like this. As a final state, we get a new position of the masses where the distance between the masses and the axis equals to 0.3. We can say the final state, initially D1 equals to D2 equals to 1 meter. And as a final state, we have D1 prime equals to D2 prime equals to 0.3 meter, okay? And we have to find omega final of the system. Okay, first of all, you know we have an isolated system. Why? Because the summation of tau here must be external, must be equal to 0. Okay? Divided by dt. In this case, L must be constant, and we get a conservation of angular momentum. L initial equals to L final. And the system is isolated system. Okay, now in this case, you know L initial equals to I initial times omega initial, L final equals to I final times omega final. Initially, we have the I told you we have I is constant of the student and the stud. So initially we have IS plus I1 plus I2, okay? I1 plus I2. Here we have M, here we have M1, and here we have M2. Okay, this is the initial one. We can say I1 initial and I2 initial. Okay, times omega initial, which is equal to the final I of the student and the stud is constant. I student plus I1 final plus I2 final times omega final. Okay. Now, you know, in the initial state, I initial equals to IS, which is equal to 3 plus I1. You know, the axis is not passing through M1 and M2. So we don't have ICM1 and ICM2. We have only M1 plus D1 square plus M2 D2 square. Okay? And the same for the final state. I final equals to IS equals to 3 plus M1 D1 prime square plus M2 D2 prime square. We can calculate, we have the value of M1 and D1. We get I initial, which is equal to 9 kilogram times M square. And also, you know, D1 equals to 1, okay? And D1 prime equals to 0.3. We can calculate the value of I final, which is equal to 3.54 kilogram times M square. We can now calculate the relation of I initial, omega initial equals to I final, omega final equals to I initial divided by I final, omega initial. We have all the values. We get 9 divided by 3.45 times 0.750. Omega final equals to 1.91. The unit will be radian divided by second. Okay. This is part 1. We have omega final equals to 1.9 radian per second. Part 2, find the kinetic energy of the rotating system before and after he pulls the weights inward. We have to find kinetic energy initial and also kinetic energy final. You know, initially, in this case, we have, you know, we have the kinetic energy of the system initially of M1, M2, and the total system. You can say equals to I initial total of the system divided by T by 2 times omega initial square. We have the value of I1, I initial and omega initial. We can write have times I initial equals to 9 times omega initial equals to 0.750 square. We get finally 2.53 joule. The kinetic final equals to I final of all the system divided by 2 times omega final square, which is equal to 3.5 divided by 2 times 1.91 square, which is equal to 6.44 joule. Okay? If I ask you about the kinetic energy, the increasing and decreasing of the kinetic energy, you can write kinetic energy final divided by the kinetic energy initial, and you can calculate the ratio of the energy.